this lecture here. And what we saw was the local maxes and local mins. Well, we had some where we had local maxes and mins, here and here. We had local maxes and mins at points like here. Got local min there, local max, local min. And then at some discontinuities also. But if you notice about how this relates to calculus is, if you'll notice that the tangent line here of those, well, they're the horizontal variety. And what about the derivative here? Well, the derivative at this point, the derivative here of those are 0. What about this point? What's the derivative there? Well, the derivative at corners doesn't exist. Okay. Same thing at discontinuities. Okay. So derivatives being 0, derivatives not existing, that's some big points. So for that reason, things happen at those things. For that reason, we're going to talk about critical numbers, and here's the definition of what a critical number is. For function f, the number c is a critical number if f prime of c equals 0, or f prime of c does not exist. And why do we call them critical numbers? Because critical things happen at critical numbers a lot of the time. Not always, but a lot of the time. Okay. All right. So let's go back to f of x equals the first one we had on that handout that we did. 3x to the fourth. F of x equals 3x to the fourth minus 16x cubed plus 18x squared. Okay, find the critical numbers for f. Okay, well, two things. To find the critical numbers, it's where the derivative is 0 and the derivative does not exist. So if I'm wanting to find the critical numbers, what's the first step? Find the derivative, right? Because that critical numbers are based on the derivative. So first of all, we're going to find the derivative, f prime here of x. Now it's easy. That would be 12x cubed minus 48x squared plus 36x. And we're back to our regular derivatives here, not the DDTs. Just a regular derivative. Did I do that right? Okay, so two things you always want to look at. Derivative equals 0, and derivative does not exist. So we set this equal to 0, 12x cubed minus 48x squared plus 36x equals 0. Factor it up. This one is very nice. Got a common factor of 12x. That would be x squared minus 4x plus 3 equals 0. And that factors a little more. X minus 3x minus 1, doesn't it? Set those equal to 0. Solve for x. Divide by 12 here, we got x is 0. Add 3 there, you got x is 3. Add 1 there, you got x is 1. So we get 3 critical numbers out of that. Okay, and you do need to think about, well, is there a place where this derivative does not exist? And is there a place where this one does not exist? Is there an x value for which I would not get a function or value out of that. No. This one, since it's a polynomial, there's not going to be any x's where derivatives do not exist. Okay. So those are my only three. The critical numbers for this are 0, 3, and 1. Now what we might note, think about to the graph on that handout, what happened at x equals 0, x equals 3, x equals 1. If we go back to the graph there, let me just sketch it right here, we had on the handout. Something like that. Here's x equals 0. Here was x equals 1, and here's x equals 3. It was the peaks and the valleys, wasn't it? Okay. Yeah, that's, well, it's the exact same thing we're saying. The derivative is 0 at those, so yeah, you have the horizontal tangent. So anyway, those are going to find those peaks and valleys for us. Eventually we'll get to do that. Okay? What about this one? Everybody got that one? Question? Still right? Okay. I'll leave the bottom part then. Okay. All right. Let's find the critical numbers for, let's just do another basic one, x cubed let me change that one up. All right. I may want to go to x to the fourth. X something. Yes. Okay, that'd be good. X to the fourth minus x cubed. X to the fourth minus x cubed. Find the critical numbers. All right. So again, critical numbers based on the derivative. So the derivative of that is what? 4x cubed minus 3x squared. (4x cubed minus 3x squared). All right, so that gives me, so for the critical numbers, I look at where the derivative equals 0 and derivative does not exist. Two things possible. All right, so the derivative equals 0. We've got 4x cubed minus 3x squared equals 0. And so that's going to give me x squared, factor it off, so it'll be 4x minus 3. We said x squared equals 0, 4x minus 3 equals 0. Solve that, of course, you get x is 0. Here, add 3, divide by 4. So we get that. Here again, the derivative does not exist. Well, there's not one because it's a polynomial, so there's nothing x can plug in to get that to do not exist. Okay, so we've got 0 and 3/4 are the critical numbers. Now, one quick point about that, if you look at the graph here, and you have to zoom in a little bit to see it exactly this way, but here's what you get. My point is here, what do I have as far as a local minimum or maximum? Well, I've got a local minimum here at 3/4. That's going to be at 3/4 right there. But what about at 0? Do I have a local minimum there? At 0, I have a critical number, but it is not a local min. So it's not always, hey, this will give me a local min or max, this will give me a local min or max. But those are the possible ones. But it won't always be that you'll get a local min or max there. Just be aware. Let me do one more real quick here. Is that okay? Okay. One more. F of x equals x to the 3/5 minus x to the 1/5. Find the critical numbers. All right, a little more difficult, I guess you might say, function. So what about the derivative? Well, the derivative here would be, 3/5 x, well, you do 3/5 minus 1, you get negative 2/5, don't you? Here you do one derivative, so you'd be 1/5 x to the, well, you do 1/5 minus 1, that'd be minus 4/5. With me? All right. Now, for what I want to do with this, here's the way I might want to write this. Let's go ahead and flip that over and make that 3/5 times 1 over x to the 2/5, and this is 1/5 times 1 over x to the 4/5. Or 3 over 5 x to the 2/5. Minus 1, 5 x to the 4/5. Okay. So I want to find my critical numbers. Critical numbers do two things. Derivative equals 0. Derivative does not exist. Set it equal to 0 first. So I'm going to set this, and let's set it this one equal to 0. Okay. So yeah, this one's a little more interesting solving-wise. How am I going to solve that? I don't think we've solved one quite like this before. But a nice, quick little trick here is you can kind of see these. I do have the fifth power and things like that. Let's. I think this will work best. Let's multiply both sides by, same thing. And let's multiply both sides by x, 5x to the 4/5. Kind of get rid of some denominators. Multiply both sides by 5x to the 4/5. Kind of the common denominator, sorta. All right, so of course that's still 0. Now when I multiply, well, let's do that one quick one first. That times that, if I do that one times that one, that's just going to make that 1. All right, then if I multiply that one, let's do that one. 3, 5x to the 2/5 times 5x to the 4/5. Here's what happens. The 5's cancel, of course. What about though? What about the x's though? Subtract. What's 4/5 minus 2/5? Don't I subtract there since they're divided? 2/5. All right, so I wind up with 0 equals 3x to the 2/5 minus 1. I think that's the way I want to go. Okay? All right? Let's move that 1 over here. Add 1 to both sides. And let's divide by 3. Seems reasonable, doesn't it? So we get 1/3 equals x to the 2/5. Now that is, the 5 denominator means 5th root, doesn't it? So this is like the 5th root of x squared. So if I have like a square root of x equals 9, I square both sides. If I have a cube root, I cube both sides. So if I have a 5th root, what do I do? 5th power both sides. Okay, so I'm going to 5th power both sides. And that's going to leave me, well, 1/3 to the 5th power. It'll be 1 to the 5th, 3 to the 5th, 3 times 3 times 3 times 3. Is that, well, 3 to the 4th, that's 243, isn't it? And then, so that would leave me, the 5's cancel, so I have x squared equals that. So what does x equal? Plus or minus the square root of 1 over 243. I got off the screen there. Where'd I go off? Okay, right here. All right, so this right here, that is 1 over 243. Was that right? 3 to the 5th equals x squared. And so that would mean x is plus or minus the square root of 1 over 243. Okay. So we get 2 critical numbers out of that. Like I said, these are the interesting ones, and we can talk about whatever we need to if you run into some problems on the homework. Now, the other thing about this one is, what about the derivative does not exist? Don't I have some places of interest here for does not exist? What would make this derivative not exist? Well, we've got denominators, and so if the denominator equals 0, the derivative does not exist. What would make this denominator be 0? X equals 0, wouldn't it? X equals 0. So since x equals 0, it would make that denominator be 0.